Hello everybody and welcome to another chat from the engineering desk. Today we're going to be talking about the next couple of sensors in the 36 sensors for Arduino kit. So in this case it's going to be the linear Hall effect sensor and the RGB LED. So that's going to be sensors number 8 and 9, I believe. So it's actually a 2-in-1, because what I've done is I've got the sensor hooked up as well as the RGB LED over here, and I've got a bit of Arduino code running. And if I bring up on the screen the serial plotter like so, you guys are going to see two things happening. You see the analog value going in change, as well as calculated analog value out, the PWM. Watch what happens to the LED when I bring the magnet near it. There's a sensor over there. Okay, so we've got our Hall effect sensor board. It's got 5 volts going to it, an analog signal out and a digital signal out. And the other side got a RGB LED. And we just lost our supply. So poke that wire back in. These things happen, but we don't worry about that. After all, we're just having some fun here. So got a magnet over there. So watch the scope value on the screen. Watch what happens to the light. As I bring this closer, the color of the light changes. So I'm fading green to red. Okay? And as I go over a certain point, green and red turn off. Now turn on blue. But blue doesn't fade, it's either on or off. Like that, see? And then you can see the value of the magnet. There's an analog value on the scope tracer on the screen. It's very neat. It's interesting stuff. So that's magnetic sensors. So let's over to the computer for a look at the code. So let's take this away. The code's very simple. Analog in pin 0. That's the green wire over here. That's the analog value coming from your Hall effect sensor. We got analog pin 9, 10 and 11. So that's going to be green, red and blue. That's the order in which they're wired up over here. Okay. We got two variables, sensor value in and an output value. Now we read the analog value in over here on this line. So sensor value is analog read, analog pin, which is analog pin 0. If sensor value is bigger than 200, we okay. Yeah. Sensor value, which is the raw value in over here. Okay, looking at the serial plotter is 460. So if we're over 200, then we'd execute this bit of code over here. Hang on just a moment, let me put my mouse dot on so you can see where I'm pointing. Bear with me for a moment. People always ask me how do I do it. Well, I use mouse highlight from catnip.com. You can get it in the Microsoft Store. So there's your tip of the day. Okay, so you open it. I don't have click highlight enabled. And then you just minimize it. Okay, and there you got a dot. That looks better. So, this line over here, sensor value between 170 and 500 becomes a value of 0 to 255. It's called a linear interpolation, right? We write that out, analog pin 1, output value. So value of between 170 and 500 becomes a value of 0 to 255 on analog output 1, that's your green. Okay. What we then do is we reverse that calculation for the red. So we output values. No, that's red. That's green because 255 minus 255 is going to be 0. Right. Yeah, so now red is going to increase as the magnet comes closer and green is going to decrease. So it's actually red, green, blue, RGB. Okay. That up there got a little confused, but it's okay. If the sensor value goes under 200, so the magnet is now closer to, very close, okay? Have a look at the value at the bottom of the screen, okay? We're going blue. So we're now under 200, okay? Like so. So what's happening is we then ignore that bit of code and execute this bit of code. So red and green get turned off by writing a value of 0 to those analog pins. It's a PWM, by the way. I demonstrated PWM in the previous video. Okay, and we say blue is 255, in other words it's 100% on. So that's why we see that happening over there. Comes on at full intensity. Okay, and there's the serial printing. So we've got two values coming out, sensor and output. So you got text, so you got inverted commas, and you got your sensor value without the inverted commas. So that's your actual, over there, result from the calculation. The same for output. And then over there, there's a 250 millisecond delay, and the program repeats. So we're doing this 4 times a second. Over there you can see it flickers 4 times a second. The reason I did that is so that when I show you the scope and I bring the magnet closer, the value doesn't scroll across the scope too fast. So you get a nice visual representation. Because if you make that time very small, a lot of data goes into the scope and your scope flows fast. Okay. And I think that concludes our little chat here on the linear Hall effect sensor and the RGB LED chip. It's nice. The digital out, as you can see over here, is also got an LED on the board. Let's see. There you go. And with this potentiometer, you can set the magnet, the threshold level for the comparator where it's going to turn that digital output on. And hence you see the LED coming on. The red one is the power LED. So you've got 4 connections over here. Okay. And similarly the same for the RGB LED. Ground and RGB. So you put 5 volts in. This has already got the resistors there between my thumb and the breadboard. The current limiting resistors for the LEDs, so you input 5 volts straight onto it. So there's no additional circuitry required or components and stuff here. So it's a nice, easy to build circuit. Anyhow, by now you're getting tired of me, so I'm going to thank you for being here. If you enjoyed the video, please like. If you want to see more, subscribe. Remember to hit the all on notification bell. And for the rest, ladies and gentlemen, have an awesome day further. See you here for more. Bye bye.